بس كده كده بعمل سبميت على
قلنا ان ده الديفينيشن اوف ليميت limit as h goes to 0 f of x naught plus h minus f of x naught divided by h. The slope القيمة اللي احنا بنحسبها دي يعني كل الأربع حاجات دول. أهم حاجة في المحاضرة اللي فاتت إنك تفتكر الأربع حاجات دول. This is the most important part, that this refers to either the slope of the graph of y is equal to f of x is equal to x naught, or the slope of the tangent to the curve y equals to f of x at x is equal to x naught, or the rate of change of f of x with respect to x is equal to x naught, or the derivative f prime at x naught at a specific point which is x naught. All of these sentences refer to the same thing. They are equivalent sentences. This is a very important concept that you need to know. You need to know that all these sentences refer to what? The same thing. This is something that we saw last time, but let's see how can we apply that definition. Application of that definition to get the derivative of sine x, for example. If we recall that sine A plus B is equal to sine A cosine B plus sine B cosine A, and that the limit as h goes to 0 of sine h over h is equal to 1, okay? And the limit as h goes to 0 of 1 minus sine h over h is equal to 0, we can use these things to compute the derivative of the sine. Now, put sine x plus h minus sine x over h, which is equal to, using this identity, minus sine x, which is sine x sine h minus 1 over h, plus sine x sine h over h, which is this limit goes to 0, this limit goes to 1, hence d by dx for sine x is equal to cosine x. You don't need to do this. There is not going to be a question for you on how to derive the derivative of sine x or cosine x or whatever. I'm just showing you that each one of the tables that we saw last time, you can use that definition to reach at these. Let's take another one, derivative of the tangent. Tan x is equal to sine x over cosine x. This is a quotient. The bottom square, the bottom times the derivative of the top minus the top minus the derivative of the bottom. You simplify, you get finally secant square x. Okay? So all of the tables that we saw last time, you can actually drive the derivative. These are going to be given to you in the exam. You don't need to memorize them. I'm just showing you how you can actually drive them if you need to. Exponential functions was a question last time that I'm trying to respond to. So this is a quick refresher on exponential functions. This is from your high school studies. Let b be greater than 0 and b to the power x is well defined if x is an integer rational number. And there is a different behavior if b is greater than 1, then this is an increasing function. B is less than 1, this is a decreasing function. The properties of this exponential function. B is greater than 0. The domain of b of x is all real numbers. The range is from 0 to plus infinity if p is thus equal to 1. It is differential, and the power law says that b to the power p times b to the power q is equal to the b to the power p plus q. b to the power p over p to the power q is equal to b to the power p minus q. So when I'm multiplying, you add. When I'm dividing, you subtract. If you are raising to the power, you multiply these two. The inverse function for the power is the logarithm. Logarithm to the power to the base b of x is a unique number such that b to the logarithm base b of x is equal to x. This is the inverse of this function. Inverse is when you put back the output in the input that you start with. Yes, was a question. Yes, sir.
How do I apply this specifier to basis?
If you have different bases, then you have a constant to multiply with. The laws of the log of any base for 1 is equal to 0. For any base, log of 1 is equal to 0. Why? Log base b for the base itself is equal to 1, so this is log 10 for 10 is equal to 1, log 2 for 2 is equal to 1, and so on. So this is a, yes sir.
معلش حضرتك سألت سؤال انا ما سمعتش كله اتكلم مع بعض ما سمعتش.
Why logarithm for 1 is equal to 0? Why? Anything before 0 equal to 1. This is the inverse function for the power. Anything to the power 0 is equal to 1. So the logarithm of 1, what will give you 1? 0. Yes. Questions? And then we have two things that we talk about. The first one is logarithm 10 for x. We simply, logarithm for the base 10, we simply say log. And logarithm for e, the natural number, we call it the natural logarithm. Where e is the limit, as x goes to infinity for this infinite sum, 1 plus 1 over x to the power x, which is 2.71828, so on. This is the natural logarithm. Now, what I would like to say is that using the definition of the limit, d by dx to e of x is equal to e to the power x. This is a very important property that I'm going to use many times. You're going to see this in physics, you're going to see this in chemistry, you're going to see this in many different places. This is, yes. This is a number that is defined such that that limit goes to 1. This is a number that is defined that limit goes to 1. Hence, I am defining it such that when I'm differentiating e to the x, natural number e to the power x will give me the same number. If any other number a to the power x, then it's len a, which is a constant. A is any constant. So 3 to the power x differentiated is equal to 3 times 3 to the power x. Okay? Yes? No? What's the problem? We are defining a number called e, which is equal to the limit as x goes to infinity for this infinite sum. Okay? Why? If I want to get the differentiation for this a to the power x, where x is a real number, then when I substitute a to the x, I end up with this that doesn't depend on h, so this can go outside, and then I have the limit as h goes to 0, a to the h minus 1 divided by h. Define a number e such that that particular form e to the h minus 1 over h is equal to 1. The definition of e is made such that that limit equals 1. I am defining it such that the limit equals 1. So when I'm differentiating e to the x, will give me e to the x. If I'm differentiating any other constant to the x, will give me that constant times a to the x. Just definitions. E happens to be 2 points, which is the sum of that infinite series, equal to 2.71828, so on.
شلون تعمل؟ ما derivative of power.
Derivative of the power, if the power is not equal to x, yes, if the power is x squared, then I need to differentiate the power itself.
2x and then
Yeah. Yeah, if the power itself is a function of x, then I need to differentiate the power itself. Then, so this was a revision, because we had a question about what's e to the x last time, and then we come back to what's the rate of change. So I started by 4 sentences. One of them was the rate of change, the other was the slope, the third was the derivative. Now, the rate of change. The instantaneous rate of change of f with respect to x naught is equal to, provided that limit exists. How many times did you write this so far? This is important. This is the definition. In a couple of months, you will only remember how to differentiate. You will forget about this definition. But a lot of concepts are related to the definition, so keep that definition in your head. Again, you don't need to memorize anything. You will find this in your formula sheet. But once you lose sight that that definition, that differentiation has a definition, you will find yourself lost. Because you go into the mechanics, I just have a function and I want to differentiate. You'll find that this huge expression, and I'm just differentiating. Nothing difficult. But that concept is important because that's what you're doing in physics right now, right?
Yes.
I'm not doing it. ده في المنزل بس ان شاء الله.
طب يعني ممكن حد يقول لك لو جيت امتحان ما جبتش قوانين يعني
لا لا الفورمولا شيت هنتفق عليها قبل الامتحان. يعني الفورمولا شيت مش هتشوفها ساعه الامتحان، هتشوفها قبل الامتحان. ولو عايز تزود عليها حاجه قول لي زود لك عليها حاجه قبل الامتحان. هنتفق ان هي دي فورمولا شيت، تقولوا لي كل اللي انتوا عاوزينه هحطه فيه. اللي عاوز ياخد الكتاب في الامتحان يا اخوانا مش دي قضيه في الماث. في الماث في كورس الماث مش قضيتي انك تاخد الكتاب في الامتحان. اللي لسه عايز يفتح كتاب ويذاكر في الامتحان مبروك عليك. سؤال؟ طيب this is what you are doing in physics these days. White please. The position at the time t and at the time t plus delta t. The position of a body moving along a coordinate line at time t, and shortly later at time t plus delta t, and this coordinate line is so s is equal to f of t, s plus delta f is equal to f of t plus delta t. So the velocity, or the instantaneous velocity, is the derivative of the position with respect to time. The body position at the time t is s is equal to f of t. Then the body's velocity is equal to the limit as delta t goes to 0 for this. You saw this before? Yes. Good. Farid has been teaching you guys well. So now this is the S is what? Position, and T is time. So I'm plotting the position of any moving object with respect to time. So this type of movement, the position S, which is the magnitude of the distance between that point that I'm measuring at the origin is increasing with a positive slope. I'm moving upwards. This is, I'm moving with a magnitude downwards. So if the slope is positive, this is I'm moving away. If the slope is negative, I'm moving towards. So velocity as a magnitude, this is something that you don't see in calculus, but you have to know very well when you are dealing with a physical problem. Where is the direction? Okay, I can be moving with the same velocity, but in an opposite direction. This is a more, we're going to see a more general case. The speed as the absolute value of v, which is ds by dt. This is the absolute value of the velocity. This doesn't take care of the direction. Acceleration is the derivative of the velocity with respect to time. If a body's position at time t is equal to f of t, then dv by dt is equal to v squared s by dt squared, and this is called the acceleration. Second law of motion for Mr. Newton tells us that if this acceleration is 0, then there is no change in velocity. And the force? Force is equal to 0? Yes. Net force. Okay? You rarely ever have a single force acting. You never ever have a single net force acting on a body. Okay? There's always some sort of friction, there is some sort of a drag. Net force acting on a body is equal to 0 if this derivative is equal to 0. And there is the third derivative if it exists. The third derivative, if it exists, we call it the jerk.
How do you experience the jerk acceleration? How do you experience the jerk acceleration? How does it affect you?
How does it affect you? Who have you tried to learn how to drive? Good. First time that you engaged the first gear and you let go of the clutch, all of a sudden, what happened to the car? Okay? That's called a jerk. This is called a jerk. It's a sudden movement because you're not only accelerating, you're accelerating
Changing
in an increasing fashion. You are increasing your acceleration. Okay? You're not increasing your velocity, you're increasing your acceleration. So, the more complex the motion is, you will find that the velocity changes in second, third, fourth, derivative. That is not, but that means that the force acting on that body is quite complex. Now we have something called implicit differentiation. What is this? Implicit differentiation. Explicit functions. Y on one side, x is on the other side. This is what we call explicit functions. I can find all the terms for y on one side and all the terms for x on the other side. What's the differentiation for this one? 3. Anybody disagrees that the differentiation dy by dx is equal to 3? Disagrees. What's the dy by dx in here? 2x. No problem? Okay. Now, implicit functions. This is the terms of x and y are on one side. Y squared plus 9yx times 4x squared, y to the 5 minus 3y squared, x squared plus 2. Now, how do I get dy by dx for these? This is what we call implicit differentiation. Yes, sir? Why, first before we go into the mechanics, why would we want to do this? Why would we want to do this? Yes.
Some functions we cannot get the x, the y,
function x. You only have an implicit form.
Exactly. If there is a particle that's moving in 2 dimensions, for example, if there is a particle that's moving in 2 dimensions, so the velocity is actually a function of
X and Y.
time and x and y. And this is, we're going to see that example in a minute. I don't have the velocity as a linear function of x by itself. No, I have the velocity as a function of both x and y together at the same time. We're going to see multiple examples on when this needs to be applied. To find dy by dx, we differentiate both sides with respect to x. And y is assumed to be a function of x. We collect all the dy by dx on the same side, everything else on the other side. We factor out dy by dx and solve for dy by dx. How is this? 3xy plus 4y squared. We'll differentiate both sides. So d by dx for this thing is equal to d by dx for 10. Now we have two terms here, 3xy, and we have 4y squared. The first one is a product of two functions. So
3y plus.
the first 3x times the differentiation of the second, dy by dx, plus the second y times the differentiation of the first, which is 3. Remember here that I'm differentiating with respect to x. So any y, when I differentiate it, I have to multiply by dy by dx. Okay? X, the differentiation of 3x is equal to directly what?
3y.
3. Officially, you can write it 3 dx by dx, but dx by dx is equal to 1. Okay. And now, this one
Is equal to
will be equal to,
No, what is that?
yeah, he just wrote 3y here. Now we take the second term. So d by dx 4y squared is equal to 4. It's a constant. We take it outside. And then the differentiation of y squared, which is 2 to y to the power 1 times, don't ever forget, and the implicit differentiation, don't ever forget the dy by dx. Okay? Which is equal to 8y dy by dx. So this one gave me 3x dy by dx plus 3y plus 8y. The green term is this. The blue term gave me this. And d by dx for 10 gave me what? 0. So when we combine, so 3x dy by dx plus 8y dy by dx is equal to negative 3y. And finally, I can collect it and put on one side. dy by dx is equal to 3y, negative 3y divided by 3x plus 8y. This is implicit differentiation in slow motion. Yes, sir. First step you didn't get. Good question. This one. Right? Okay. I have two functions multiplied together. X and y. This is a function in x, and this is a function in x. I have to say that the first times the differentiation of the second, plus the second times the differentiation of the first. Differentiation of y is dy by dx. Differentiation of 3x is equal to 3. Okay? Okay? Now, let's find the tangent line to this x cubed plus y cubed is equal to 9xy. How do we do that? Again, we are differentiating everything. X cubed. When we differentiate, we get 3x squared. y cubed. We get 3y squared times dy by dx. Don't ever forget dy by dx. Y itself is a function of x. Is equal to 9x dy by dx plus 9y. Why did we get this? You tell me. Look at this right hand side and tell me how did I get from differentiating 9xy? How did I get this?
Differentiating the 9xy relative to x,
Uh-huh.
so we get 9x. And we get 9y.
This is two functions multiplied together. 9x is a function, y is another function. The first times the differentiation of the second. 9x times the differentiation of the second, which is dy by dx. Plus the second, which is y, times the differentiation of the first, which is 9.
Differentiation of the first. And we have 9x. Differentiation of 9x.
لا لا. The first time the differentiation of the first as itself, 9x, it goes without change, times the differentiation of the second.
Yes.
Okay?
The product.
The product rule exactly. Okay? We're good? Okay, so now we simply rearrange the terms to get dy by dx on one side. So dy by dx times 3y squared minus 9x is equal to 3y minus 3x squared. Okay? So the final result, dy by dx is equal to 3y minus x squared divided by y squared minus 3. I don't really care about simplifying this. I don't care about simplifying this. It looks what it looks like.
Firstly, could I write instead of dy of dx y dash? It's easier for me.
This is a good question. Our friend here is suggesting that instead of writing dy by dx is equal to y prime. Do we agree or not?
Yes.
Absolutely. These two are equivalent. Now, when you are solving the homework, feel free to use whatever notation you like. We can read both. In the exam, the answer is going to be given to you. You just need to simply pick the right answer.
And secondly, I oriented it differently, and it's just the same terms, but the signs are different. It's okay.
Yes.
It's just the opposite way around.
It's fine. So we'll go back to the original. We did not want to find out what the implicit dy by dx is. We wanted to find the slope. So at the point 2 and 4, so I'm just gonna substitute 2 and 4 in this equation. I get 4 over 5, and hence the equation of the tangent is equal to 4 over 5x plus the intercept, and the intercept I can calculate it from the equation of the line
The
itself.
point to
Yes, sir.
It's for any x.
No, he's asking me to calculate the slope of the tangent line at a specific point.
To calculate
So
the equation
So
for
dy, by dx, which is this is the equation of the tangent, is equal to m by x plus b. I calculate m
For any
from
x.
this, and I calculate b. Then the equation of the tangent becomes mx plus b.
This defines the tangent to any x, to any point on the.
No, at that particular point. That equation is going to be different any other point. This is important. This is the equation for the tangent to the curve at that point. Obviously, if you substitute for m with any other values, you get a different slope and a different intercept.